At this point, we've seen three right-hand rules, one for cross products, one for wires carrying a current, and the last one is for loops carrying a current. We'll use this activity as a summary of our two right-hand rules that involve wires, specifically wires that are in a straight line and wires that are bent around and form loops. For wires carrying some current I, our right-hand rule for wires is to point our thumb, specifically the right thumb, in the direction of the current, and if we were to do that, our fingers curl in the direction of the magnetic field. Here are three examples where either the current or the magnetic field is missing. Go ahead and pause the video and draw in either the current or the magnetic field for each of the cases shown. For the example on the left, the X's tell us that the magnetic field produced by this wire are directed into the page, whereas the dots tell us that the magnetic field is directed out of the page. If I were to point my fingers so they go into the page on the left side of the wire, then wrap around as if I'm grabbing the wire and point out of the page on the right side, my thumb is directed down. That means that the current in this wire that created that magnetic field is directed down the page. Repeating that same process for the middle example, now I curl the fingers on my right hand so they point out of the page on the left side of the wire, wrap around the wire and point into the page on the right side. Now my thumb is pointing up, and so is the current for this wire. In the last example, we're told that the current into the page is represented by this X, and this thing is actually our wire. Now what I'll do is I'll point my thumb, which represents the current, towards the page or into the screen, wrap my fingers around in a circle. My fingers are curling in a clockwise direction. That means that the magnetic field produced by this wire are loops, and the direction is clockwise, and these are supposed to be circles. We've also seen a right-hand rule for loops of current. And so in this case, for our loops of current, our right-hand rule for loops is that our thumb points in the direction of the magnetic field inside the loop, and our fingers then curl in the direction of the current. For each of the examples shown below, go ahead and pause the video and use the right-hand rule for loops to determine the missing quantity. For the example on the far left, the missing quantity is the current that creates that magnetic field. For the middle example, the magnetic field is missing, and again, the magnetic field is missing for the example on the far right. For the example on the left, I'll point my thumb into the page and then curl my fingers. My fingers are curling in a clockwise direction, which means that our current that produced that magnetic field is clockwise. It's not shown, but the magnetic field produced by that current outside of the loop is out of the page. So whatever the magnetic field is inside the loop, it's the exact opposite on the outside part of the loop. For the middle example, now I'm given current, I need to find magnetic field. This current is counterclockwise, so I curl my fingers on my right hand counterclockwise, mimicking how it's shown on the paper, and my thumb is now pointing out of the page. So inside our loop here, our magnetic field is directed out of the page, and then on the outside of the loop, it's the exact opposite. The magnetic field is then into the page. For the example on the right, this X at the top tells us that the current in this loop is going into the page, and the dot at the bottom signifies the fact that the current is coming out of the page. And this figure, again, is obtained by rotating something like the figure that's in the middle 90 degrees so that it's on its side. Applying our right-hand rule for loops, I point my fingers into the page at the top of the loop, curl my fingers around so they're pointing out of the page at the bottom. My thumb is directed to the left. That means that my magnetic field through my loop is directed to the left, and then I can sketch in some magnetic field lines representing this fact. We will be using these right-hand rules for loops and wires many times in our study of magnetism, so it's nice to have this page as a reference page for in the cases where we might forget, how do we do our right-hand rule for wires? How do we do our right-hand rule for loops?